So today we're going to discuss an architect who's kind of shaped the discourse on architecture as we know it, and maybe the most famous architect of our time. So I'll start with this, and after this we'll go through all of your site analysis presentations, so you'll have a chance to present all of that. This will be kind of a dress rehearsal for Wednesday. So, yeah. We don't have a presentation right now. We just have stuff. Well, we're going to get it as close to a presentation as we can in the next hour or so. So we want to be able to present what you have as a way of kind of getting ready for Wednesday. All right, so that's going to be the goal. I found that these presentations are best when there's multiple presentations rather than just throwing you into the fire on Wednesday. So you're going to get as far as you can today, and we'll take that next step. All right, so that you can get feedback and clean it up for Wednesday. So Dean's also put it on the board here. Our research presentation in front of the AIA is going to be Wednesday. So that should be on the calendar. It's going to be around 5. I'll let you guys know the details pretty soon as to what exact time and the location. But yeah, so we're going to talk about Frank Gehry and talk about his work. Like anything in this class, we're not just interested in the product, but in the process. So we're going to talk about his design process, what formed his theory on architecture, and how he kind of positioned himself in the profession. He's very, very much unusual in a lot of the theory and a lot of the kind of stance he has as an architect practitioner, but he also considers himself an artist. And so we'll talk about that framework and how he's kind of positioned himself in the profession and made a name for himself over the years. In 1947, Gehry and his family immigrated to Los Angeles, where he soon began taking night classes at LACC, LA Community College. He studied architecture at USC between 1949 and 51. And then he studied city planning at Harvard. He worked for several architecture firms, including Victor Gruen and other noteworthy architects. In Paris, he started his own company, Frank O. Gehry and Associates, in 1962, and then its successor company, Gehry Partners, in 2002. His architecture reacted to the often cold, kind of static, almost sterile architecture of modernism. So his work was taking the rigidity of modernism and making it playful. He wanted to introduce humanity back into architecture. So he considers himself this kind of response to modernism that had kind of taken over. So you see in this quote, he says, as an artist, I got constraints. Gravity is one of them, but within all those constraints, I have 15% of freedom to make my art. What do you think some of those constraints are in architecture? Yeah. Okay, cost, budget. Okay, structural concepts. So making sure the building stands up. We have a lot of structural constraints that most artists don't have. So him calling himself an artist kind of plays into this conversation of, well, we do have more constraints than most typical artists. Do you have something? Yeah, the building code. Yeah, these are all constraints that we have. And often the best solutions find ways to work within those constraints, but still achieve what we're looking for, still use them as opportunities to create, interesting work. So he began to experiment with kind of an unusual, expressive design vocabulary. So he was always interested in, creating art versus architecture. While he was at USC, he made friends with a lot of the artists in that area, in the community. That architecture program shares a building with the art program. So he made a lot of friends that were artists, and he always saw himself one of them rather than the architects in that building. So that's an important connection too. He was making friends outside of architecture. And I think that's one of those things that we as architects as a profession need to be able to do. We need to be able to get outside of our comfort zone, get outside of the conversations among other architects, and speak to people outside of the profession, because you never know who those clients are going to be. It's not often the architects that will be our clients, it's often the rest of the world. So he kind of had this built-in niche of contemporaries who were, the avant-garde artists at the time. In 1978, he ended up renovating his home in Santa Monica. He had done a number of projects, homes for his artist friends. Those were a lot more minimal. He was, interested in, and very much inspired by kind of the simplicity and Japanese architecture at the time. USC was taught by a lot of modernist architects, and so his work was kind of a response to that. When it came to remodeling his home in Santa Monica, it was kind of an interesting approach. So there was an existing structure, relatively historic-looking building that he decided to expand the footprint of. But rather than using traditional materials and matching this existing kind of gambrel roof, he decided to use industrial materials. He used corrugated metal. He used raw plywood, chain link fence. This is a model of the house. And you can see just the kind of bold moves that he made. And a lot of this was starting to form this deconstructivist language, taking architecture down to its primitive structural components and taking it apart, expressing it, exposing it in a different way. As you can imagine, this wasn't received well by the community. Santa Monica was kind of, that neighborhood was up in arms. People would drive by and think that it was an active construction site. So there were drive-by shootings at the house. And you can see, just how bold these moves were. But what he's doing is he's taking apart the traditional boundaries, the traditional layers of a house, kind of unpeeling it and treating walls and roofs, kind of challenging what a wall is, taking it apart, decomposing it. You can see some of the, the architectural moves, taking these large chunks of the building, rotating them, skewing them, seeing the building as a series of layers in a radically different way compared to the original house, which really had one envelope. Now he's kind of challenging where the house starts and stops. And again, you can just see how bold that statement is, to have chain link fence, surrounding and creating the sails and the ornamentation, something that most modernists would cringe at on this house. In '88, Frank Gehry was officially designated the winner of the Walt Disney Concert Hall Commission. Originally, this building was designed with a limestone veneer. This project, the concept was to create an outdoor space. He wanted this garden to be incorporated into the music hall. It's going to be across the street from the Dorothy Chandler Pavilion. So it had a lot of, the site itself had a lot of historical significance. This is a place in downtown LA that was undergoing a revitalization. This was kind of the business and financial center of LA. A lot of the banks, high rises were just down the street. So he really had a kind of a passion for this part of the city. And growing up in LA, he had a connection to LA in a way that, most other foreign architects maybe wouldn't understand. The climate, how much we, need to be outdoors, and how important that is for any, even enclosed building like a concert hall. So his idea was, let's create this outdoor garden experience. This would all be glass on the right, and that would be this, outdoor garden experience. He saw the significance of this corner. So this is Grand Avenue, and the idea was that this would be a significant corner, again, addressing the Dorothy Chandler Pavilion across the street. His left hand is on the Dorothy Chandler. And again, it started out as this kind of terracing limestone geometry, still expressive, but it wasn't until 91 that he unveiled the final shape of Disney Hall. Estimated price tag was $110 million. That would eventually escalate to more than double that. But you can see the forms that this evolved to, just going from here where it was, single curvature. You can see there's curvature in the facade, but it's really just kind of in one direction. Now to double curvature, a surface curving in more than one direction. So we'll talk about his process, but you can see the influence of model making and paper. He's interested in taking materials and finding their imperfection, and not just smoothing over that imperfection when the building is built, but highlighting it and emphasizing it. That's really what separates him from other contemporaries. Most architects will find ways to have either smooth, flowing geometry and, hide any imperfections, the detailing, the facade components that are really difficult to build. He took on those challenges and said, let's find a way to build this. And so part of that ambition led them to using technology that was outside of architecture. In order to realize a facade like this that has double curvature, they had to look to software that architects weren't using at the time. There was a software called CATIA. It's a aircraft design software. And it was really the first parametric software, one of the first, I would say, to be used in architecture. So with parametric software, you make a change to one part, let's say the fuselage of the aircraft, and it'll have ripple effects of changes to the structural components, maybe the electrical, mechanical. All of that is going to be impacted by that one change that you make. So rather than the analog method of manual drafting or digital drafting, where you're having to change every strut in the building or every structural member when you change the facade, with parametric design, you're able to make one change and it affects the rest of the building. So he took this software, CATIA, his office. They said, what if we reappropriate that into architecture? So they took this software, CATIA, and they worked it and reworked it and called it Digital Project. So Digital Project was designed for architects, and it allowed architects to design parametrically, where again, moving the facade changes the structure behind it, changes all the standoffs, all the rest of the building is going to react to that one change. So now we can work in a more efficient way, but we can also realize and build architecture that couldn't be built before. Something like this, to communicate that to a builder is extremely difficult, right? We learned in the Sydney Hall how the curvature was based on a portion of a sphere. Well, if you deviate from that, it becomes a lot more difficult to communicate to a builder each arc of that project, unless you have a digital model that captures all that information. Okay, so he started this commission, and you noticed how different it was at the beginning. He had since then gotten another commission in Spain, in the town of Bilbao, that project came along, and it was revolutionary in that they wanted to revitalize the city. They had commissioned, the Guggenheim Museum had commissioned their latest museum to be built in Bilbao, but to revitalize what had previously been a port city. It hadn't been the thriving, arts and cultural capital that it is today. So he had gotten this other commission in Bilbao. This project had already, started design, and then they unlocked this revolutionary technology and parametric design through digital project. All of a sudden, they're able to not only design, but build complex curvature like this, catenary surfaces, double curved surfaces, and they were able to realize this kind of new form, new design language in architecture. And so you can see the connection between music and the geometry. It was about movement. It was about expression. Again, he wanted to bring humanity back into the buildings we design. So it wasn't enough to have architecture look like it's standing still. There should be movement. Okay, so you can see the idea of movement, his connection to the corner, right? This is still a very significant corner, even though there's no sculptural object there. It's really about the opening and kind of the subtraction of that space leading you up to this entry. Since then, he's completed the Grand Avenue development across the street, mixed use, high-rise project that also has a lot of interesting vantage points, kind of framing his Disney Hall across the street, being very self-referential. And then the Broad Museum was built just beyond this by Diller Scofidio Renfro. So this area has become kind of an arts cultural district of Los Angeles. And you can see the digital model and how all of this, every curve in this building, all the structural steel behind it, all of that is designed. You're not leaving any of that up to the contractor to interpret. So reducing the amount of interpretation in the design is one of those things that every architect needs to learn if they want to realize their work. And so you can see in the floor plan kind of the strategy taken where the concert hall itself is almost this enclosed shoebox, and everything else, all of the sails, kind of form the perimeter enclosure, but they don't really, there's not a whole lot of, those sails, you experience them from the exterior, and then you're inside the building and you see some curvature, but the experience, you really want to be able to experience that, the most impactful part of the building. In this case, it's those sails. So there's a few walkways that you can kind of get lost in and meander around the building and experience that. This is the entry. And again, you can see these sails kind of lifting and peeling apart where the entrance, the main entrance is. It's very hard to get sheet metal to curve in more than one direction without this oil canning effect you kind of see on the right. This building, when it was built, was so reflective that some of the concave curvature was acting as a lens effect, and it was causing all the buildings and apartments around it to heat up to really high temperatures. So they had to brush the metal and made it a more matte surface versus a reflective, shining surface. Some of the interior geometry is just as playful, but there's a lot you can do with plaster and drywall and wood on the interior. The interior was designed acoustically, so they had an acoustic engineer design the interior, making sure that the acoustics were such that performers, when they were practicing, it had the same resonance value as when the auditorium is empty versus when it's full of people. So they wanted it to be able to, the artists to be able to practice and have the same kind of reverberation in that room, empty versus packed with people. So the seat cushions, the acoustic panels, all of that wood, and you can see a lot of convex geometry in the ceiling. That's to reflect sound in multiple directions, rather than a concave geometry, which would focus sound, causing strange kind of acoustic anomalies. I mentioned that Bilbao project. So Frank Gehry often starts with very gestural sketches. These sketches are very loose. They're not meant to, be a one-to-one as to what was built, but they're meant to capture the essence of the massing, of movement. So he's famous for these sketches. There's even a Simpsons episode that featured him. So he's very much part of popular culture. And so these sketches in Bilbao, they started around this idea of movement and movement of a fish. So this project is on the water. There's an existing bridge that you can see the silhouette here. So adjacent to a bridge, how do you engage the bridge but still kind of build around it? So what he did is he kind of put the bulk of the building here. The tail of this goes under the bridge, and then there's a tower that kind of peaks up on the other side. So as he's working out the program for this museum, he's thinking about form as an artist would, composition, materiality, impact, emotion. These are things that an artist would deal with. Architects typically would, but a lot of that, he would argue, has been lost. So he's thinking about form and massing and proportion in a different way. And I think that's what most architects actually gravitate towards in his work. So we talked about CATIA. So this is a computer-aided 3D software. And it was groundbreaking in that it allowed these moments of ingenuity to occur, and that they were able to not just design it digitally, double curved surfaces, but actually fabricate and construct it. So developed between 91 and 1997, the curved and angular titanium-clad building was conceived at the turning point between analog and digital practice. Back then, architecture firms were distinguishing themselves by saying we're a digital practice, meaning we're using AutoCAD, we're using the computer. Back then, hand drafting was predominant, and hand modeling was still it was part of the design process. And so it's interesting how at the same time, while Frank Gehry is pioneering this advanced aerospace technology for the architecture, he's still going back to hand and physical models to create the forms and gestures that he's interested in. So he's going, starting with what he's familiar with, the tactile, physical aspect of modeling, of sculpting, but then he's experimenting with new technology in order to realize those imperfections, those little creases that show up in paper that, again, most architects would try to smooth over in the digital model. He challenges his employees to show that imperfection in the building design. So this profound shift kind of permeated every aspect of the project, from design and construction techniques to the method of communication in the technology. So how do you communicate to a builder where that sale needs to be, right? So all of that was worked through in this digital, really digital fabrication process. You can see some of the framing during construction, the space frame needed for those sails. It's a essentially a truss in 3 dimensions, so curving in multiple directions, and then clad with titanium. Like we said, the building is on the water, and it creates these really epic, dramatic views with the water in front of it. And for Bilbao, this acted as a catalyst for development and culture. So they wanted to invigorate they wanted to invigorate tourists to start coming to Bilbao. And since this, there's been a huge boom in the kind of artistic and cultural aspect of it. So it went from this industrial port city to a cultural hub for Spain. Inside, there's very sculptural architecture. You can see how he was designing this to match the large-scale artwork that's inside. Richard Serra, famous artist, known for his canted Corten steel shapes. You can see the reflection of the artwork in the architecture. There's various philosophies in architecture as to the role of architecture in an art museum. Should the architecture just become a blank tabula rasa? Should it be a blank canvas to the artwork so that the artwork can show? Or should the architecture be the art itself that attracts people to and dialogues with the artwork? There's various strategies there. So Frank Gehry, you can kind of see the approach that he took. The Louis Vuitton Center in France, this was kind of the next step and an interesting take on, again, the sculptural nature of the work. Here, looking at translucency as the kind of catalyst for the design, how it can glow. So using exposed glulam beams, these are all bent glulam wood arched beams, framing, combination of steel and wood, and then clad in this curving glass. So creating these indoor-outdoor spaces, again, tying back to his original house that he designed for himself, breaking the boundaries of where that building starts and stops, kind of fragmenting it, and bringing the building massing out into the landscape. You can see in these sails how reflective the glass is. Again, the digital model showing the section cutting through all of this. And again, you're seeing the challenge of something that happens in paper reflected in the digital model, where if you were to take a piece of paper, fold it, part of it would fold and crease over, and then part of it would be smooth. And again, rather than trying to just rationalize that entire geometry, smoothing it over, he's saying, I want to see the seam here. I want to see these edges as, an arc, but I want the double curvature of the actual surface to be expressed. So it's this unique dialogue that, as an architect, we have to have. How much of this do we want to be just rationalized, cleaned up, smoothed over? How much do we want to have these imperfections show up in the final built design? So you can see the exterior versus the framing, some of the night shots, and you can see how this thing is like a glowing, smoldering icon. This project on the Vitra campus was a gallery. Vitra is a furniture maker. They make high-end custom, not custom, but high-end furniture. This is in Wein and Rhein, Germany. The Vitra campus itself is the home for many famous architects. They've had Zaha Hadid, Herzog and Demeron, Frank Gehry, Buckminster Fuller has a geodesic dome there, Alvar Aalto. A lot of famous architects, all these Pritzker winners, have built work on their campus. And this project, kind of similar to the Frank Gehry free-form gestural moves, but with very modest materials, stucco and standing seam metal. So this is a very, relatively modest design for Frank Gehry. But you can see a lot of his playful shapes and geometry. Again, thinking of the building as a sculpture. And then how light can play with those forms, again, like a sculptor more than an architect. And he was inspired by fish. He was inspired by the movement of koi in a koi pond and how that could be translated to architecture. So this motif of the fish kind of worked its way through a lot of his work. And you'll see that this is in Barcelona, this large sculpture that he designed, but inspired by the curvature of fish and the connection to the sea that Barcelona has. He experimented with a lot of furniture. This is a corrugated cardboard chair. So all of these laminations are cardboard, and again, creating a playful shape out of an otherwise industrial material. So something he was interested in. Other steam bent plywood furniture. Again, taking a normally rigid material and making it playful, this ribbon-like kind of bending of the plywood. Other thermo-molded furniture he also designed. And to his critics, so one of his critics once asked him, how do you answer to those who accuse you of practicing showy architecture? This was his response. He was very bold, and his quote, he says, let me tell you one thing. In this world we're living in, 98% of everything that is built and designed today is pure shit. There's no sense of design, no respect for humanity or anything else. They're damn buildings, and that's it. Once in a while, however, there's a small group of people who does something very special, very few. But God, leave us alone. We're dedicated to our work. I don't ask for work. I don't have a publicist. I'm not waiting for anyone to call me. I work with clients who respect the art of architecture. Therefore, please don't ask any questions as stupid as that one. So for him, he's bold, but he also stands behind what he does, and he sees his work as a departure from the rest of the kind of movement of architecture. So he saw his work as being this kind of departure from the clean modernism, sterile architecture that he kind of was taught throughout school and was prevalent, throughout that time period. So I think the lesson here for young architects is to realize that it's okay to use new technology to realize new forms of architecture, even if those original ideas come from analog processes like physical model making. Again, thinking about his process, it's this hybrid of old and new technology. But in the end, it's not about the technology at all. It's about the architecture that he's able to realize by combining the two. So I think as architects, we need to start challenging the media we're using, the tools, the software. Can we start bringing in new technologies to the field of architecture? What are we missing right now that we're not incorporating? What are other industries doing that we can learn from? Let's bring that into architecture rather than finding passions and then leading us away from architecture, right? The world of architecture is important, and the world needs architecture. So we need to find other industries to bring that technology into this dialogue. All right, so I'm gonna stop sharing. Any questions?